All right, so for this one here, we're asked to sketch the graph of the function and find the area under the curve between 2 and 5 using 6 left endpoint rectangles for the function x minus 1, and then write the sigma expression that represents the area. So I'm going to go a little bit off script on this one, and I'm just going to kind of go with the flow on how I would solve this. So when I'm graphing this here, because I'm told that I'm going from 2 to 5 and there's 6 left endpoints, I'm going to find the width here by doing 5 minus 2 divided by 6. So we have another problem here where the widths are just 0.5. So they're not always going to be 0.5. This is just kind of the simpler problems use a width of 0.5. I'm going to use this a lot, so I'm going to mark it up here. Second thing is I'm actually going to start plotting some points on this graph. So I need all the points between 2 and 5 going up by 0.5, right? So I got 1, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5. Actually, I don't need that. So 1, 2. I'm going to mark this down real quick. My scale is a little bit off here, but you should see that I'm going up by 0.5s. Now I'm going to use an x and a y table just to plot these points for me using my function f of x here. So I got my 5 and I'm going to find all the y values here. Okay, so I used my x and y table to find all those points. I plotted them on my graph here. Now going forward, I am going to start breaking this up into different rectangles. So in this case here, because they're left endpoint, I'm using the left sides as my heights. Oh, this is not the prettiest of rectangles here. All right. So one thing I'm going to notice for sigma notation later is that I'm only really using these first values here. Actually, let me do this. I'm going to call them subscript notations here. X of 0, x of 1, x of 2, x of 3, x of 4, and x of 6. And if you notice, all the heights of my rectangles are the left sides, so I don't even really use this x value here. That's going to come back to help me later. The other thing I'm going to do here is I'm going to create an x of k table in blue here with those subscript notations there. So I go from 0, 1, 2, 3, 4, and 5. I could do 6, but I know already I'm not using that one, so not really that important. And then just as a reminder, the x of k's are actually x values. That's why it says x there. So we're just using 2, 2.5, 3, 3.5, 4, 4.5, and again, not using that one. Okay, so from there, we have our rectangles. We know our width of each of the rectangles. I'm just going to mark the heights of them, which we already know from my y values, but I'm just going to point them out on my graph. 1, 1.5, 2, 2.5, 3, 3.5. Those are all my heights. And now I'm going to take some time to multiply all of the widths times heights. I'm going to write this down in expanded form so that you can see it, because again, I'm wanting to show you what it looks like. You could probably just do it in a calculator and be good to go. You wouldn't have to show this. Now again, problems like these you'll probably get calculators for, so you can just plug this in to a calculator. You could get each individual one if you want, or just plug it all in one big string of things, which is what I did. And I ended up getting my area of 6.575 units squared. So that's my area. Again, I just found the width, and then I found all the heights, and then I multiplied them and added. Sigma notation a little bit tougher just because I got to use this light blue table that I created to come up with an equation that's going to help me with that. So my equation here, because I see I'm going up by 0.5 each time, x of k, I'll do it down here actually, x of k equals 0.5k, and then when my k value is 0, my x of k value is 2. And remember, x of k is always going to be a linear function. Okay, so sigma notation. Now here's the tough part. Sigma notation, because remember here I said I'm only using the k values from 0 to 5. Well, that's where I get this bottom k equals 0, top number is 5. Now I need to basically find the width, which I already know, and the height, which is going to be 2 equations in one. The width, if I look back up here, is 0.5. So second version here, k equals 0, 0.5. And then remember when we found the heights of my rectangles, I used the y values of this function, meaning I'm just going to use x minus 1 for my height here. The only thing is that I'm really going to use an equation for x instead of just an x value. Because remember, in sigma notation, I'm using k to plug numbers in. So final answer here is going to be sigma notation from 0 to 5. 0.5 is my width. 0.5k plus 2 are all my x values for my height plugged into this equation from my original function. So this is my sigma notation. And yes, you could simplify this a little bit more if you wanted to, but I'm going to go ahead and leave it like that.